Barangaroo station is a key part of Sydney's metro network, enhancing urban connections. Sydney Metro works in collaboration with Infrastructure New South Wales to deliver it. Our risk management plan ensures cost control and adjusts the key risks through advanced tools, including the evaluation contents, risk register, and the framework of standard requirements. This approach results in a clear contingency plan and a detailed management strategy.
Hi, my name is Harry. I'll be discussing the scope of works involved in the construction of the Barangaroo metro station, which consists of two primary scopes within the overall project: the station works and external works. The station works involves excavation, the construction of the underground station platforms and station entrance, as well as the full fit out of the station, including all essential services, finishes and fittings. The external works includes the realignment of Hickson Road, which runs adjacent to the station, as well as the public domain works, which includes foot and cycling paths, tree landscaping, external paving and street furniture. The baseline estimate establishes that the total cost for the Barangaroo metro station project is $206 million. Within this figure, costs are broken down amongst the three project phases. Design and engineering, which will cost $8,918,000, constituting 4.33% of the total base estimate. Procurement, which will cost $1,500,000, representing 0.73% of the total base estimate. And construction, which will cost $176,868,000, equating to 85.85% of the total base estimate. Furthermore, an additional cost for the head contractor's overheads and profit has been allowed for at $18,728,000. The base estimate assumes that there will be a stable economic environment with no fluctuations in labour, plant or material costs. The baseline schedule demonstrates that the total project duration for the Barangaroo metro station is 67 months, beginning on the 1st of May 2025 and finishing on the 5th of January 2031. Within the 67-month baseline schedule, design and engineering will take 19 months, amounting to 28.36% of the total base schedule. Procurement will last for 4 months, representing 5.97% of the total base schedule. And construction, lasting 44 months, constituting 65.67% of the total base schedule. The baseline schedule assumes a 7-day work week, working regular hours from Monday through Sunday, with work continuing through public holidays. Additionally, it also assumes constant productivity and resource availability, as well as no forecasted adverse weather conditions.
Risk identification for this project categorizes 30 risks across different phases, 4 in design and engineering, 3 in procurement, 20 in construction and 3 for the whole project. These risks are further classified into 7 inherent and 13 contingent risks. This structured approach ensures a comprehensive understanding of potential uncertainties. Combining quantitative and qualitative tools in our risk management provides a balanced approach. Quantitative tools like cost-benefit analysis provide data-driven insights to evaluate probability and financial impacts. Qualitative tools such as SWOT analysis enhance decision-making based on expert judgment. We applied likelihood tables, consequence tables both with 5 levels, as well as the escalation tables and the risk matrix. There are 1 to 25 scores from logical assessment process and generates low, medium, and high levels for each risk. We have 5 methods to deal with risks: reduce further probability of occurrences, and mitigate it to reduce the severity of a consequence. Accept for extremely small risks and avoid super severe risks. Some risks are more cost-effective after processing. Also, we have proposed detailed treatment methods for each risk. Regarding the top 20 risks, we focus on medium and high risks and selection from low risks based on previous projects and expert recommendations. For example, although collapse is a low risk and only has 4 scores, it has a great impact on schedule, reputation, and cost, so it was selected. In the quantitative risk register, each risk corresponds to task 1 by 1, directly obtain base schedule and estimate for ML, BC, and BS calculations. For multiple risks involving the entire process, reasonable assumptions are applied based on historical data.
Hi everyone, this is Annie and I'll walk you through the quantitative schedule and cost risk analysis, which is later used to assess and allocate the schedule and cost risk contingencies for the Barangaroo metro station project. Using a QIA model, we apply probabilistic methods to assess the top 20 of both inherent and contingent risks. Starting with 3-point estimates, best case, most likely, and worst case, we calculated P50 and P90 confidence levels using Pearson turnkey formula to guide contingency decisions. For the QSRA, we conducted Monte-Carlo simulations identifying a base schedule of 253 weeks. The analysis showed a required P50 schedule contingency of 362 weeks and P90 of 474 weeks. Similarly, the QCRA indicated a P50 cost contingency of 276 million and a P90 of 347 million. We then addressed allocation and control. A P50 confidence level was selected for this project as it promotes cost efficiency, avoids inflated budgets, aligns with industry norms, and enables effective portfolio-level risk management. The vertical and horizontal allocations were conducted. Vertically, the P50 contingency was split 70% to contingency reserve and 30% to management reserve. For schedule, that's 77 weeks to CR and 33 weeks to MR. For cost, that's 74 million to CR and 32 million to MR. CR is part of the performance measurement baseline and managed by the project manager, while MR remains outside the PMB and is controlled by the project director. Horizontally, CR is distributed across the project lifecycle. 60% is allocated to late-stage activity just before completion, and 40% is spread across design, procurement, and construction phases using milestones. So now moving on to the control measures. Schedule contingency is managed through a structured change and recovery process assigned to the project managers to decide as part of the entire schedule management framework. For cost, the Delta contingency framework allows for reallocating or retaining the unused funds based on ongoing risk assessment.
Hi, I'm Ziyi. I represent the integrated risk management strategies for Barangaroo metro stations, focus on three frameworks: the governance, risk, and compliance or GRC framework, the assurance framework, and data analytics framework. So starting with the GRC framework, governance begins with shareholders and flow through directors to specialized committees like safety and planning, nominations, remunerations, and research and development committees, ensuring each domain is carefully managed. Executive management oversees implementations, while the Barangaroo project team delivers on the ground. Risk is managed through a 6-stage process: identify risk, analyze using qualitative metrics, ranking and trading through mitigation plans, then monitored continuously via dashboards with clear communication to stakeholders. For the compliance, we follow critical legislation including the New South Wales Working Health and Safety Act, the Building Code of Australia, and the Environmental Impact Statement. This indicated how risks are identified, controlled, and reported. And we move on insurance framework. The assurance framework complements by providing a structured, stage review process. We adapt a 6-gate model starting from project justifications and business case validation to readiness for service and final benefit realizations. Each gateway includes health check, technical deep dives, and audit reporting. Independent technical audits, WHS reviews, and quality assurance system checks. This approach ensures that risks are identified early and that mitigation strategies are embedded in both planning and execution phases. The data analytics framework brings intelligence into risk decisions. We collect both qualitative and quantitative data from systems like baseline estimate and quantitative risk assessment models. The data is used for predictive analytics and contingency allocations. Using a P50 confidence level, we've allocated 76 weeks and 73 million in contingency reserves. These are split horizontally across the life cycle stages, including design, procurement, and construction, and vertically based on responsibility and decision authority.